class we have done the van der Waals, Redlich-Kwong, Redlich-Kwong, and the Peng-Robinson. So we have done so we have also discussed that there are three sets of equations. One is the first class equation of state, which is basically cubic equation of state. Second class equation of state, non-cubic, but analytic form is available, just like Benedict-Webb equation and all those stuff. And third class equation is very specific, and sometimes analytic form will not be available. Mostly, I will be talking about the first class equation of state, and that's what we have discussed. And we have found that equation of state, cubic equation of state, which is the evolutionary waves, so van der Waals. Number 2 is the Redlich-Kwong. Number 3 is Swave, Redlich-Kwong, and number 4 is Peng-Robinson. Number 4 is Peng-Robinson. And these are all cubic equation of state. And what we have found, that equation of state, what we are interested on, that we are interested on vapor and liquid, both the phases. The equation should be valid for not only for the gas, it should be valid for the vapor, it should be valid for the liquid phase. So if one would like to draw PV diagram, this is the physics prediction. Physics will say this is the liquid part, this is the saturated liquid part, saturated vapor part, and between the vapor liquid. And if you want to zone up the vapor liquid plus vapor mixture, and this is the last point where the liquid exists, beyond the liquid is gas. So this is the generalized perspective of the cubic equation of state. The generalized perspective of cubic equation of state. This could be valid. So when you this is from physics, and from mathematics, one can actually have the solution like this. This dotted line from mathematics, and this equation, this solution from mathematics will be changed depending on the equation of state you select, like van der Waals, Redlich-Kwong, Redlich-Kwong, and the Peng-Robinson. And we also proved that, not proved, we stated that these two areas are same. That means this spurious solution, of course it is a spurious solution, it doesn't, it says that along this branch dou P by dou V at constant temperature is positive, which is not visible. And hence that is not accepted. And if one would like to calculate integral PdV, as also discussed, the work done, we can directly go from here, go parallel and go this, and it will be equivalent if you take this entire part, because this area equal to this area, so it doesn't matter, so you will get the same work done for the. So that means if I want to have work done from the liquid to vapor phase, although phase change is occurring, earlier we didn't know. Calculate integral PdV. You closed your eyes, used RT, dV and all those things to solve the thing. But now, if you have a liquid to vapor, you know here the phase change, so all you need to know the saturation pressure, Psat. All you need to know Psat. All you need to know Psat. The saturation pressure is known. Then you can say this is my initial pressure, this is my Psat, and from Psat to these branches as gas phase. So here you use liquid phase property, here you use gas phase property, and this zone where your pressure is constant, you know the work done is Psat into Vg minus Vf. This is Vg, this is Vf. So you know the work done in this branch, you know the work done in this branch, you know the work done in this branch. So that's the way when the phase change process occurs, in knowing the saturation pressure, one can calculate the integral PdV or the work done. Okay. And we are trying to solve last class the equation of cubic equation of state, like van der Waals. Only we have done for the van der Waals, but there is a generalized format which is called analytical method, which we are going to discuss in today's class. So we'll talk about something called generalized cubic equation of state. That means you have a cubic equation of state. You have cubic equation of state. The question will arise whether we get analytical solution. The question will arise whether we get analytical solution, and yes, if we get analytical solution, how to get it, that's the thing. And if you get analytical solution, it is pretty straightforward. The thing is that we all know that quadratic equation is very straightforward, but the cubic equation is not that straightforward, and that's what we are going to address in today's class. So I will take one of the generalized equation of state. By now we have got all the form of the equation of state. So van der Waals, Redlich-Kwong, Sweeper-Kwong, and Payne-Robinson, where P equals to RT by B minus B minus A by V square UVB plus WB square. Most generalized equation of state. I think it falls along the Payne-Robinson, right? It falls along. So RT by V minus B. This is similar for all the van der Waals, Payne-Robinson, SRK, RT. But this will actually change, and it is A by V square plus UVB plus WB square. And now, so this equation we can express in terms of compressibility factor. In terms of compressibility factor, which is Z, compressibility factor Z. So that means we can define Z is, you have the definition of compressibility factor? PV by RT, and Z equals to 1 from the ideal case, right? And people say that Z equals to 1, that means limit P tending to 0, PV by RT equals to 1. This V is the molar bond. So quite often people talk in terms of compressibility factor. Compressibility factor 1 is for the ideal test, other cases, other things. So it comes in later details of the compressibility factor. So this equation we have to express in terms of the polynomial of V. We have to express in terms of polynomial of V, and from here we know that V equals to Z RT by P. So can we express first the polynomial of V, and then we proceed further. So what we will do that with in this, or you can directly write this as function of Z, whatever, or FB or FZ. So we can write this as RT by Z RT by P minus V. Okay. So substituting V by Z RT by P, right? Substituting V by Z RT by P minus A by Z RT by P whole square U V Z RT by P plus WB square. Now you get, now I give you the task, we'll get this kind of term into Z RT minus V PV equals to P RT into minus AP square. Okay. So how many terms will be there? How many terms will be there? Three terms. Okay, can you please tell me what are the terms? What are the terms will be there? Any idea? Z square r square t square. Z square r square t square plus UB p z r t plus W b square p square, and then next this term, there goes 3 terms here and 2 terms there. Same terms. So z square r square t square plus UBP z r t plus W b p square p square, and AP square will be z r t minus PB. Okay. Now we get z cube plus, so we get a polynomial of z. We can see the highest power is z cube. Highest power is 3. So z cube, z square plus z plus some constant term equals to 0. What will be those terms? What will be those terms? You can see that z square and z multiplied z cube. So now you can see what are the coefficients for z cube. What is that? Any hands? Any hands? Divide. Yes. Yes. r cube t2. Z square. Z square. What are the coefficients of z square? What's the coefficient of z square? How many terms will be there? First tell me. 3. He is saying 3. 2 terms. Somebody is saying 2 terms. How many? What is the right answer? 3 or 2? 3. Can you tell me now?
One will be r square t square t b
minus
r square
t r square t square b.
Then it will be minus p r
cube t cube. Yes. One last term is there. You do plus UBP
r square t square
Yes, you are right. UBP square r square t square. Am I correct? Z now. How many terms for Z? Any idea? How many terms for Z? Four terms. Yes, you are correct. So who will volunteer? Please raise the hand if you are sure for all the terms. Otherwise, again, I will have to ask somebody else. Who can give me the answer? Z multiplied by
QB square PQ RB.
that is plus or minus? Yes, madam. Can you run it? 4 terms do you have? 3 terms. 4 terms. Who can have 4 terms? You have 4 terms? Yes, you can please volunteer. Minus UB p square r square. Yes, madam. Very correct. Next. A plus AP square RT, yes madam, plus omega W, it is W not omega, plus W plus B square P cube RT, then one more term is left, minus minus UB square P cube RT, right? Yes or no? Minus UB square P cube RT. Last term, there are only three terms. Last term is only three. What is the last term? Last term, last bracket has only three terms. Last bracket has only three terms. Last bracket has only three terms. You have all the three terms ready? Yeah, tell me. Minus AP cube. Again, you are just neglecting minus or plus. If you neglect minus, dangerous. Okay. Minus AP cube B all plus, huh? You are saying plus, that means you are neglecting sign. I want the correct sign. I don't want to neglect you to neglect plus or minus. Sign is very important. If you neglect sign, you get wrong result. Anybody has ideas? All the terms will be negative, positive. How many terms will be negative? How many terms will be positive? All negative. Yes, you are correct. So you have the terms for me. Yeah. Minus W B cube P to the power 4
minus RT P cube W B square
minus W B square P cube RT. Yes, madam. That's it. So now I introduce a new variable. I introduce a new variable A, which is AP by RT whole square, and B is BP by RT. Capital A is AP by RT whole square, and capital B is BP by RT. If you divide the entire equation by P R cube T cube, you will get Z cube plus alpha Z square plus beta Z plus gamma equals to 0. So dividing by P R cube T cube, you will get Z cube plus alpha Z square plus beta Z plus gamma equals to 0. Now can you write alpha, beta, gamma in terms of AB, capital AB? No small business, no RT will come, because RT is actually included in capital AB. So then a very simple form, alpha. What will you get alpha? How many terms will you get alpha? 3 terms, right? Yes. Can you tell me? After dividing with this, what will be alpha in terms of capital A, B and other terms? A, B, U, V, W. All these terms are allowed. No P, no system term will be there. No pressure, no temperature, no R, because that all will be substituted. After dividing P cube, R cube, T cube, you substitute this and you get alpha, beta, gamma. What is alpha? What are alpha, beta, gamma? 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 Any ideas? First divide by P R cube T cube, you will get Z cube term, Z cube form, and then after that you have to introduce A equals to AP by RT whole square and B, capital B is BP by RT. If you do that, you get cubed alpha, beta, gamma terms. What are those terms? What are those terms? What are those terms? What are those terms? Any luck? Is this so difficult problem? Have you got it, madam?
So minus d by p minus 1 plus b.
Only 3 terms with very simple terms. Just anybody? Yes, and please, yes. Yes, you are very correct. Minus 1 minus capital B plus UB. Next. Some of you got it? Yes. Next term, beta. Next term, beta. Beta, there will be 4 terms, right? Because beta Z, and Z has how many terms? 4 terms. Beta is, yes?
Minus b into p. Sir, minus d by p
A, alpha, beta you got, right?
is
Alpha is minus 1 minus b plus UB. It is correct. It is correct. It has been verified for last couple of years. It is not, I am not teaching the first time. It has been verified from the book, from my derivation, and last couple of years. So if any mistake, you try it out. It is not that difficult to find the mistake. You can find out. If you cannot find out now, you can go home and find out. No problem. Next we go to beta. You got all the terms? Yes. What? W? No, it's wrong.
First term will be minus u.
Minus?
And u will be
Don't, you have all 4 terms? Please don't guess.
first
Yeah, please do it. Don't, yeah, I don't want you to impress anybody. If you do it for yourself, your benefit is better. It is not that I am not giving any credit who are answering me. I am just interactive so that you are learning in the class as much. You go home, you should not be troubling. Yes, sir. Thank you. Tell me.
minus u b square
Minus UB square
plus w b square
plus WB square
minus u b
minus UB.
plus a.
Yes, sir. 100% correct. Gamma. 3 terms. Gamma, 3 terms. Gamma, 3 terms. Have you all got gamma? If you just divide by P R cube T cube, if you do that, everything is solved. If you divide by P R cube T cube, everything is solved.
minus w b cube
Minus WB cube
minus w b square
minus WB square
minus a b.
minus AB. No RT. Done. Very correct. So you got the cubic equation. This is a very compact cubic equation of state. This is a very compact cubic equation of state in terms of compressibility factor. So now I have given a table to you. One table is there where alpha, beta, gamma, those forms are given for different equation of state. Have you got it? One handout I have given. There are 2 handouts given. Van der Waals, U, W, alpha, beta, gamma, everything is there. So what you do then for equation of state, pick up any equation of state. If you pick up any equation of state like SRK and Payne-Robinson, we have P equals to RT by B minus B minus ATC alpha 1T divided by B square plus UBB plus WB square, and here it is again RT by B minus B minus ATC alpha 2T by B square plus UBB plus WB square. U, W, everything is there in that table. The small table you have, that table you have with U, W. So this term will contribute somewhere. So now you can see this alpha 1t and alpha 2t, it will be there in somewhere in this term. So there you have to be very careful because that's a function of temperature. Every temperature, this equation will be changed, the solution will be changed. Van der Waals equation is temperature independent, right? In that way, it is of course temperature dependence is there, but it should not come here. This term is temperature free, right? This term this term is also very complicated here for the SRK and RK, where temperature dependency is coming. In that A term, interaction parameter is a temperature dependency. Earlier we had only temperature dependency only via this term, but we have got complications here, so we have to handle it very carefully. The solution procedure of this equation of state in terms of compensating factor can be obtained by which method? Carnot's method, as I told you earlier. So z cube alpha z square plus beta z plus gamma equals to 0, that can be solved by Carnot's, method. This equation, if you take it as such, is very difficult to solve analytically. So what we will do, we will define z equals to x minus alpha by 3, right? We have seen it, right, earlier. So if you do that, what will you get? You substitute z equals to x minus alpha by 3. If you substitute x minus alpha by 3, what will you get? I will say that I will get x cube plus px plus q equals to 0. Now question is, what is my p, what is my q? So substitute x minus alpha by 3 whole cube plus alpha into x minus alpha by 3 whole square plus beta into alpha by 3 x minus alpha by 3 plus gamma equals to 0. If you take it out, you will have a minus b whole cube, which is a cube minus b cube minus 3ab into a minus b, right? Am I correct? The formula is there. If you employ the formula, a minus b whole square is there, a square minus b, a square minus 2ab plus b square. You have the formula. If you incorporate the formula, you can get, and then you will see some cancellation of the x square terms. X square terms will get cancelled from here and here with this. If you cancel it out, can you tell me what are the p and q? Can you please tell me what are the p and q? So what I am saying that if you do x minus alpha by 3 whole cube plus alpha into x minus alpha by 3 whole square plus beta into x minus alpha by 3 plus gamma equals to 0, and we have x cube minus alpha cube by 27 minus 3 into alpha by 3, 3x into alpha by 3 plus 3x into alpha by 3 whole square plus alpha into x minus 2x alpha by 3 plus alpha square by 9 plus beta into x minus alpha by 3 plus gamma equals to 0. So what are my p and q? What are my p and q? And you can see that this is having alpha x square is x square is 2 alpha square by 3. This is 3x square. Sorry. Correct it, 3x square by alpha by 3. If you do that, what are you getting?
P will be beta minus alpha square by 3.
P is beta
Minus alpha square by 3.
minus alpha square by 3, and Q is
Alpha cube by 27 plus alpha cube by 9 minus alpha beta divided by 3.
Q you are not getting. P is perfect. P is perfect. But Q you are bold. Any ideas for the Q? P is correct. If you get P, Q is quite straightforward. Q is the constant term. Constant term will be collected from here, collected from here, collected from here and here.
4 alpha cube divided by 27 minus
No.
2 alpha cube divided by 27
27 minus beta alpha by 3 plus gamma.
Yes, sir, very correct. 2 alpha cube by 27 minus alpha beta by 3 plus gamma. Right? Right?
Yeah.
Okay. Some mistakes will be there, don't worry about it. Silly mistakes I also do. So, but finally you should get the correct form. So, you got the very cute form of the equation of state. X cube plus px plus q equals to 0. Very, very cute form. How to solve this equation? Now, I'll assume x equals q minus b. I'll assume x equals q minus b. X equals to u minus b. So my equation is u minus b cube p into u minus b plus q equals to 0. Okay. And we have the formula u cube minus v cube, which is u minus b whole cube plus 3ub into u minus b. Okay. So my equation is, first equation is this one, and we get, first equation I should say this one, x cube plus px plus q equals to 0 is my first equation. And from here you can write u minus b whole cube plus 3ub into u minus b minus u cube minus b cube equals to 0. Equation number 2. This is my more fundamental equation. This is the formula of u minus b, u cube minus b. If you look at these two equations, they are the same because I am assuming x equals q minus b. So if you compare the coefficients, you get x equals to u minus b, p equals to 3ub, and q equals to minus u cube minus b cube. Am I correct? Yes? Yes? Okay. And then you can pick up this equation and try to solve it. So if I pick up this equation, so if I pick up q equals to minus u cube minus v cube, what will you get? Q equals to minus u cube minus p cube by 27 u cube, because we know that p equals to 3ub, so v equals to p by 3u, v equals to p by 3u, okay, v equals to p by 3u, so you get equation in terms of u. What is the equation you get? In terms of u to the power 6 you get, in terms of u to the power 6 you can get. What's the final equation? What's the final equation? You get u to the power 6, in terms of u to the power 6 you get. What's the final form of the equation? What's the final form of the equation? Final form of the equation?
U power 6 plus
E to the power 6 plus
Q U power 3
q to the power 3 minus p by 3 whole cube equals to 0. And from here, if you put u cube is some unknown, say y, then you can get in terms of your quadratic set, and you get the equation solution as u cube equals to minus q plus minus q square plus 4 into p by 3 cube by 2, and v cube equals to plus q by 2 plus minus, you can say, yeah, minus, I will just write in a very compact form, minus q by 2 plus minus q by 2 whole square and p by 3. Am I correct? Very compact form. One is minus q by 2 plus minus square root of q by 2 whole square by p by 3 whole cube. Another is minus q by 2 plus minus q by 2 whole square plus p by 3 whole cube. And this quantity I term as delta. It is called, some term called delta. It is called delta. So depending on this delta, you can get different kind of solution of equation of state. So delta can be 0, delta can be greater than 0, less than 0, and delta can be greater than 0. First case I will take second case I will take greater than 0, and last case is less than. That will be interesting case. I will come back. If delta equal to 0, I don't want to do the solution in the class. Now your job is to, now you have learned how to come. You got the solution. If you put delta equal to 0, just see how much you are getting. You go back, you get x. You go back, you get z. Right? Finally you have to get z. U minus b is equals to what? U minus b equals to x. X is what? X minus alpha by 3 equal to z. Once you get z, your job is done. So those part, I don't expect, the derivation you do in the class. You can go back home, do it slowly, and you can get it. But interesting, the results are very, very interesting. If delta equals to 0, first case, if delta equals to 0, what you get? Number 1, delta 0, you get Z1. You get Z1, which is minus 2 q by 2 whole to the power 1/3 minus alpha by 3 minus 2 q by 2 whole to the power 1/3 minus alpha by 3 and Z2 and Z3, which is q by 2 whole to the power 1/3 minus alpha by 3, which is also q by 2 1/3 minus alpha by 3. So please go back home, kind of do the derivation. I don't want to do the class because you can do it. It is just algebraic manipulation. I am not teaching algebra in the class, and also I don't expect to give in the exam this derivation. You should know the results are very interesting. What it says that all roots are real, and two roots are equal. Z1 is not equal to Z2, Z3, but Z2, Z3 are equal. Z2, Z3 are equal. So two roots are equal, one, and all are real roots. All are real roots. That means in your diagram, if you look at in your diagram, I think this will be representing this zone, and three roots will be getting, and one will be spurious. One will be your spurious solution. Okay, one will be your spurious solution. That's what I wanted to include this part in the exam, because if I give a problem, what I have done in the last exam, you can do by Cardan's method is much easier. If you say Cardan's method is not included, you have to do iteration. So tell me what you want. You want me to include this part, Cardan's method, way to solve? Otherwise, you have to do iteration technique. Iteration will take you more time. Exam time is 50 minutes. So because formula is supplied to you, you don't have to mark up anything. Because you have the one A4 size sheet, you come with A4 size sheet. I don't want you to derive. That is not the syllabus. You need to apply the formula. I will calculate delta. I will solve the problem right after this. So you know how to solve the problem. Okay? So you don't have to have because this thing included means your life. I want to make this simpler. Why to go for iteration technique? Iteration means you don't know when it converts. If it doesn't convert, your head will grow. Identical solution means first attempt you will get the convert solution. Okay. So case 1 is over. So delta equal to 0 most in this zone. You will get the solution. At this point, we will see what kind of solution we get. So next case is delta greater than 0. Delta greater than 0. What we will get? You get one is real, Z1 is real, and Z2 and Z3 are complex. Z1 is real, Z2, Z3 are complex. In fact, this solution you will not get in this case. This case will be different because here Z2 and Z3 will not be similar because V is different, so Z will be different. So this case will be somewhere else. We don't know. We have to see. which case we will be presenting delta equal to 0. But delta greater than 0 means Z1 is here and Z2, Z3 are complex. I will give you a formula for Z1, which is minus q by 2 plus root delta to the power 1/3 minus q by 2 plus root delta to the power 1/3 minus alpha by 3 minus alpha by 3 minus alpha by 3. So case 2 we found that delta greater than 0, you get 1 real root and 2 are complex. Complex root I don't want to give because you don't need complex root because you want to have only already real roots. Third case is delta less than 0. Third case is delta less than 0. There you get all different real roots. Third case delta less than 0. We will get all three different roots. Z1, Z2, Z3. So Z1 equals to 2r to the power 1/3 cos theta by 3 minus alpha by 3. Z2 is 2r to the power 1/3 cos theta plus 2 pi by 3 minus alpha by 3. Z3 is 2r to the power 1/3 cos theta plus 4 pi by 3 minus alpha by 3. R and theta I have to give. R is minus p by 3 whole cube whole to the power half, and cos theta is given, which is minus q by 2 square root of minus p by 3 whole cube. So delta less than 0 will get three different roots of Z1, Z2, Z3, and R is given by this. Cos theta is the other things are known. Alpha and all those things are known. This part is obtained by from de Moivre's theorem in complex algebra. De Moivre's theorem, I think you know that. E to the power I theta equals to cos theta plus I sin theta. So in this part, if you actually employ de Moivre's theorem, you can actually get this. So again, I am not denying that. You can go back home and do it for yourself. So this is this three are unequal, and this is the case for this part. Here you get three unequal roots. The first case, when you see Z2 and Z3 equal, you won't get. What is Z? Z is PV by RT. So you have VZ or VF. So both the case Z is different. The same pressure and temperature. Pressure is saturation pressure. Exact. And in the VG and VF means temperature is same. Only this is different, means Z will be different. So for this zone is delta less than 0. So if somebody asks you to finding out the solution, mostly delta less than 0, and give you the easy path, you have to employ this formula, find the solution. No need to have any hassle for iterative procedure. Now we will do the sample problem. I think the assignment is with you. Assuming that N butane obeys the van der Waals equation of state, calculate the molar volumes of saturated liquid and saturated vapor at 427.85 Kelvin and 0.215 megapascal. The van der Waals constants are A equals to 3.789 Pascal meter cube per mole square and B equals to 2.377 meter cube per mole. Use Cardon's method. You get this problem? Yes? What's the number? 10A. Or not 10, huh? 10A. 10A. Yes, 10A. Problem number 10A. Okay?